Number 2 on your homework. As you can see, we're trying to determine if the triangles are similar, and all the information that we have is a side, an included angle, and a side. So if the triangles are similar, remember their sides are going to be proportionate, meaning their ratios will be equal. Well, we see that the angle measure included, the included angles are congruent, so that's one qualification that we need for similar triangles. So we're good there. Now we got to test the sides. So the first thing I do is I label in each triangle my smallest side and my largest side. In triangle WYX, 18 is my smallest, WX is my largest. Now that I've done that, I'm going to set up my ratios. I'm going to set up the big triangle ratio compared to the small triangle. So I'm going to compare side lengths of triangle KLJ to side lengths of triangle WXY. Just to remind yourself that the bigger triangle side lengths go on top on the numerator and the smaller side lengths go on the denominator. So I'm going to first compare my smalls, 20 over 18. And I'm going to see if that ratio equals my large ratios, 36 over 24. If you type 20 divided by 18 in your calculator, press math, enter, enter, you're going to get a ratio of 10/9. That means that when you type 36 divided by 24, if these are similar triangles, you should get 10/9 again. But 36 divided by 24, math, enter, enter, gives you a ratio of 3/2. 3/2 is clearly not equal to 10/9. So they are not similar. And we can just put an X through the similarity statement because they're not similar. So there can't be a similarity statement. Number 4, same thing. We have a side, an included angle, and the included angles are congruent in both, and then a side. So first thing I'm going to do is compare my side lengths in each triangle. This is the small side, this is the large side, this is the small side, this is the large side. So when I set up my ratios, I want to set up small over small, large over large. And first I'm going to use triangle DKJ over triangle PRZ. This just helps me remember not to skip around. If I do 8 over 4 first, I can't do 9 over 18 second. So I'm going to do 8 over 4. I'm going to do my smalls. Set them equal to my larges, 18 over 9. And 8 divided by 4, 4 goes into 8 2 times. And that should equal 18 divided by 9, which is also 2. So since the sides are proportionate and the included angles are equal, congruent, they are similar by the side angle side similarity. Now, to do my similarity statement, PRZ, well, P to R to Z goes small to large. So I have to have the same pattern in the second half. D to K to J takes me small to large. Okay, number 9. Well, I'm going to go ahead and draw these triangles out separately because it makes it easier for me to see what my included angles are, which side lengths I'm comparing, and how to find my missing variable. So this is going to be triangle QSV, and then the little one RST. Well, this whole length of SV is 36, and this length, ST, is 24. Well, I can go ahead and label that here. If the whole length of SV is 36, and 24 of that is ST, then to figure out what VT is, we just subtract 24 from 36. So that must mean that this is a 12. So 24 plus 12 is 36. So the total length of SV is 36. Then we have RS, which is also going to be 24, and X. So this one we don't even need to set up a proportion. If you can understand that this is 24, this is 24, this is 36, and QS is 36, because they gave it to us, then x must be whatever's left over, which we said is 12. Now, to do our similarity statement, we want to make sure that we match correctly the side lengths to the angle lengths, or angle measures. QSV goes from the side 36 to 36. So we're going to have to be careful when we go in the little triangle. We want it to go 24 to 24. So RST. And then finally, number 12. This is something we haven't talked about in a while. We got parallel lines here and a transversal. So we have a set of corresponding angles here and here. We also have a transversal going this way, so we have a set of corresponding angles at N and P. And the reason they gave us that information was so we can prove that these two triangles were similar by the angle-angle similarity. Now, in order to set up our proportions, well, we know that 30 is the small side over 32, the other small side. That should equal the big side, 30 plus 10 is 40, over 32 plus x. Remember to put your quantity in a set of parentheses that will remind you to distribute. So cross multiplication, we have 30 times 32 plus x, and that should equal 32 times 40. 30 times 32 is 960 plus 30x, and that equals 32 times 40, which is 1280. I'm going to subtract 960 from both sides of my equation. 1280 minus 960 gives me 320. That equals 30x. Divide both sides by 30. Gives me 10.67, which I'll just say 10.7, rounding to the nearest tenths. Going back up for our similarity statement, RFQ, R to F to Q, goes 2 arcs to nothing to 1 arc. So the same pattern in the second triangle would be NFP, 2 arcs to nothing to 1 arc.